Okay, welcome to this flip session of chemistry. Today we're going to be talking about something that's extremely important in chemistry class, especially at the high school and early college levels, and that's the mole and how it relates to grams and molecules. So when you're looking at the mole to gram ratio, you have to consult the periodic table. And the bridge that connects the amount of moles of a substance and the grams of a substance is the molar mass. Once again, you get that number directly from the periodic table. Okay? So think of the mole and the mass. The idea that bridges the two together is the molar mass. And every atom in almost every substance has a different molar mass. So you're going to need your periodic table for this one. So some mole to mass examples. So if I look at carbon, the periodic table tells me that it's the sixth element, which doesn't tell me the molar mass, but tells me the number of protons in the nucleus of the carbon atom. That gives almost like the thumbprint or the identity of the carbon atom. If it's got 6 protons, it's carbon. So 1 mole of carbon, looking at my table, is 12.01 grams. So that's the molar mass of carbon. The molar mass of hydrogen, for example, is 1.01 grams. The molar mass of helium is 4.00 grams. Okay, they weigh differently, they mass differently per mole. Okay. When we're calculating mole to mass problems, what I like to do is simplify things. And it's a real simple formula. Whatever they give me, whether it be moles or grams, whatever is given, I call that my given unit. Whatever they want me to go to or convert to, I call that my desired unit. So I write down my given unit and I multiply that by my desired unit over my given unit. That way, if I do this correctly, just like math class, my given units cross out. And I'm left with my final answer. Okay? For example, if I wanted to convert grams of carbon to moles of carbon, okay, my grams are my given unit, in this case, 24.67 grams, and my desired unit is the mole. So I'm going to put the mole on top divided by what 1 mole of carbon is in grams, and that's 12.01. We got that right up here from the periodic table. If I wanted to go from moles to grams, I would have to flip that conversion factor, right? This is an exact number, so it's not going to determine my number of sig figs. So 24.67 has 4 sig figs. 1 mole of carbon is 12.01 grams. That's an exact number. That's not going to determine my number of sig figs. This number is, the given. So 24.67 grams divided by 12.01 grams gives me this long, ugly number that I have to chop to 4 sig figs. 2.054 moles of carbon. Well, what if we venture out and we don't strictly look at mole and mass, but molecules? So 1 mole of any substance on the periodic table is Avogadro's number, which is 6.02 times 10 to the 23rd units of that substance. Really strange concept, but if you simplify it, we can look at it and compare it to a dozen. In the English language, if you say 1 dozen of anything, you have 12 items of that substance. In chemistry, which is a whole other language for a lot of folks, if you have a mole of a substance, not a dozen, but a mole, you'd have this huge number, 6.02 times 10 to the 23rd parts of that substance, not 12. Okay? Here's where things change a little bit more. So 1 dozen of anything is 12 items. A dozen dump trucks, a dozen markers. But they don't weigh the same. Their masses change. we know that 12 dump trucks would definitely weigh more than 12 of these markers. And the same goes for chemistry. A mole of any element, any compound, anything, always has Avogadro's number of atoms or molecules, but they don't weigh the same. Some atoms are bigger than others. They weigh more, have more mass. Another example of a conversion factor would be if I wanted to go between carbon atoms to moles of carbon, I would take my given information, which would be carbon atoms, in this case 1.68 times 10 to the 24th, and I would use this conversion factor and flip it in a way that I can use it to my advantage to get moles of carbon. So in this case, my given unit atoms must be in the bottom of this fraction to cancel out the atoms up here. And what I compare is what they want me to convert to, moles to atoms. 1 mole of carbon has Avogadro's number of carbon atoms. So 1.68 divided by 6.02 to the 23rd, once again gets me this long, ridiculous number, and I chop it to 3 sig figs because this number in the problem has 3 sig figs. Once again, as a quick reminder, folks, exact conversion factors don't determine our number of sig figs. So the analogy that I like to use is, if you've ever been to Boston and you've ridden on the T or some subway station similar to it, you've got the orange line and you've got the red line and the blue line and so on and so forth. And there's different intersections where you can jump from one track to another. Okay? I call this the Molar Roadmap. Similar to the T in Boston, if you want to go from one place to another, sometimes there's not a direct line of subway that gets you there. You have to take it to another colored line subway and then travel from there. Okay? So, for example, if you wanted to go from atoms or molecules of a substance to the mass, you can't really go there because things weigh differently. But the one place you can always go to is the mole. This is like North Station in Boston, where a lot of connections meet. Okay? So this is a simplified version of the Molar Roadmap. If you want to go from mass to moles, divide by the molar mass of that substance, whatever it may be. You'll have to consult your periodic table for that. If you want to go from the mole to mass, you do the opposite operation. You multiply by the molar mass, or ml. If you're trying to go from atoms to moles, divide by Avogadro's number. And that goes for all substances, because all substances have Avogadro's number in 1 mole. And to go from moles to atoms / molecules, you multiply by Avogadro's number. Okay. A quick reminder, you always multiply out of the mole. Some kids find that helpful. Multiply out of the mole. So now you try it. Take a moment, pause the video, convert 600.5 grams of iron to moles of iron, 16.75 moles of boron to grams of boron, 1.4 times 10 to the 12 chromium atoms to moles of chromium, 12.67 moles of calcium to atoms of calcium, and 15 grams of gold, Au, to gold atoms. So pause the video now and take a stab at this. Okay, so let's take a look at some of our answers here. So my grams were my given unit, so I have to have grams in my denominator. And this is a conversion factor, right? This is the molar mass of iron, 55.85 grams. And this has 4 sig figs. So 600.5 divided by 55.85, rounded to 4 sig figs because of this number, I get 10.75 moles of iron. Okay, problem letter B. 16.75 moles of boron is my given unit, so I have to have moles in my denominator. This is the molar mass of boron from the periodic table. So my number of moles times my molar mass, moles cancel, and we're left with 181.1 grams of boron. Once again, this number doesn't dictate sig figs, nor does this number, because it's an exact number. This is the number that dictates sig figs, which is 4. Okay, letter C. I have chromium atoms, that's my given. My relationship between the mole and the atom is Avogadro's number. It's going to be the 2 sig figs. So 1.4 times 10 to the 12 divided by Avogadro's number is 2.3 times 10 to the negative 12 moles. Okay, these last couple of problems here, I couldn't fit on the board. So part D, if you have 12.67 moles of calcium, and you're trying to get that to atoms, once again, that's my given mole, so it has to go here to cancel. So 1 mole of calcium is Avogadro's number of calcium atoms. So if I calculate this, I should have an answer to 4 sig figs because of this number. So 12.67 times 6.02 second function EE to the 23rd to 4 sig figs, I get 7.627 times 10 to the 24 calcium atoms for part D. Okay. And lastly, our last problem here, you can see that, let me get out of your way, I might be blocking that. Remember, you can pause these flip videos and replay them at any time. Right, that's the goal here. I'm going to erase this. And the last problem, so you have the answer here, letter E was 15 grams of gold, 2 atoms of gold. Okay, well, this is tricky. We're trying to go from mass to atoms, and there's no direct route. So this is a 2-step problem. So remember, always go to the mole when in doubt. Okay? So my given unit is grams, so I'm going to use that on the bottom here, and I have to get that to mole. So 1 mole of gold is, I think it's 179. Let me double check myself here. $196.96. I was off. I was thinking of something else. Okay. So the molar mass of gold is 196.96. So 15 grams divided by 196.96. I'm going to keep that number. I get 0.076, and it keeps on going. I'm going to hold on to those digits and round to the very end. And to get this to molecules, right, I'm going to take 1 mole of gold has Avogadro's number of gold atoms. Gold atoms. So essentially I'm taking my answer and I'm multiplying it by Avogadro's number. And my final answer to 4 sig figs is 4.585 times 10 to the 22nd gold, aurum, from Latin, right, gold atoms. And that's today's flip session. Blah, blah.